this final video on scientific notation, I just wanted to work through 4 examples of what we've seen, just to review a little bit, so that you get a little bit more comfortable with these types of examples. So the top 2 are about converting, here from standard notation to scientific notation, here from scientific notation to standard notation, and these 2 are about solving the operation. Here is multiplication and here it's division. So let's start with the first one. So we have the number 0.0026 and we want to pass that number to scientific notation. So what we need to do first is identify which are our important numbers. So in this case it's 2 and 6. So we write first the first number 2 and we put the decimal and the 6. And times 10 to the, and we need to determine what the exponent is. So in this case, the number is less than 1. It's a small number and it starts with 0 point something, so it's going to be a negative exponent. So we put the negative, and then we figure out how many places you need to move the decimal point so that it goes from here to the 2.6, so between the 2 and the 6. So we started out here and we have to move it 1, 2, and 3 decimal places in order to get it to 2.6 from where it was. So it's negative 3. So that's the final answer. 0.0026 is the same as 2.6 times 10 to the negative 3 in scientific notation. Now let's move on to the next one. So we have 8.5 times 10 to the 3. So the first thing we do is, again, write the important numbers, which are the 8 and the 5. And we used to have the decimal point here, but we want to move it 3 places to the right. It's going to be a big number because the exponent is positive, so we're going to move to the right. So we had it here, and we're going to move it 3 decimal places from the middle of the 8 and the 5, 1, 2, and 3, and it's going to be out here. So we fill up the rest with zeros, and the number that we get is 8,500. So we can write it prettier if we want to, just so that it's more clear. Oh, and by the way, in this class, we're going to use the period as the decimal point, because that's the way we do it in English internationally. And the comma means thousands. So that's 8,500, not 8.5, just in case. Okay, that's how we solve the second problem. Let's move on to the third problem. So now to multiply, we only worry about multiplying the original number, the number that is not in the exponent. So that is 3 and 9. 3 times 9 is 27, so we write 27 times 10 to the, and to figure out the new exponent, we add the numbers because we're multiplying. So we need to add the 7 and the 6. 7 plus 6 is 13, so we put a 13 here. And we would be done, but our number here is not between 1 and 9. We need to make it between 1 and 9. So we're going to have to put a decimal point between the 2 and the 7, giving us 2.7. And we're going to have to change the exponents so that these 2 numbers continue being equal. Because if we keep the 13, we no longer have the same number. So because we made the new number smaller than the original number, it was 27 and we made 2.7, we need to add a number to the 13 so that it compensates. So it decreases to 2.7, so this increases by 1 to 14. That's how we know if we should decrease or increase. So that's finally our answer in scientific notation. That's example 3. And in example number 4, we have a division. So we divide the original number. We have a 4 and a 5. If you put 4 over 5 in a calculator, you're going to get 0.9. Nope, 0.8. Sorry. Yep, 0.8. That makes more sense. Okay, so we have 0.8 times 10 to the. And to figure out the exponent, because we're dividing, now we subtract. So 9 minus 7 will give us 2. So we have a number 0.8 times 10 to the 2. But again, as here, we need here a number that is between 1 and 9, and we have a 0, which is not between 1 and 9. So we're going to have to move the decimal point 1 place to the right in order to get an 8 in front. So this is going to become 8 times 10 to the something else. So because we made this number bigger, we need to make this one smaller in the exponent by 1. So 2 minus 1 will give us 1. So the answer to this division is 8 times 10 to the 1. Just an extra hint, if there's no number in the exponent, it's because it's a 1. Because 10 to the 1 is equal to 10. Everything to the 1 is equal to that same number. 5 to the 1 is 5. 72 to the 1 is 72. So if you ever see just a 10, like for example here, if you just see 8 times 10 to the 10, it's the same thing as 8 times 10 to the 1. So just take that into account as you're solving the exercises for today. And those are the examples.